In this problem, we want to solve a logarithmic equation because we have x, the variable, in the log itself. So the goal is to get it into one single log and then convert it into exponential form, or to be able to set some expressions equal to each other. So first things first, let's get it into one expression. So you're going to get log base 3 x times x plus 3 equals 1. And here we are in logarithmic form. Can't do anything with it. So now I'm going to convert it to exponential form. So that's going to be 3 to the first power equals x squared plus 3x. Now what I need to do is I need to get this to the other side. So now here I have 0 equals x squared plus 3x minus 3. Now here we have a quadratic, and we can solve quadratics by graphing square roots, completing the square, factoring, and the quadratic formula. Ideally, we want to be able to factor these because they're easier to do, but in this particular example it can't be factored. So the quadratic formula is going to be the easiest way to solve this. So we know that x will equal minus 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, and times negative 3. And this is all divided by 2 times 1. And when you simplify this, we get roughly negative 3 plus or minus. This is negative 4. This is 4, negative 4 minus 12. So minus 3 is 12, positive 12, plus 9 is 21. So the square root of 21 divided by 2. And so we could simplify this and convert it to a decimal, but this is the exact answer, and that is fine for me. Actually, when you look at this problem, you think, oh my gosh, I can't do it. But it's a very simple problem. You have b, log base b, log base b. So for these two logarithmic expressions to equal each other, whatever's in here has to equal what's here. So then you get 3x minus 4 divided by x plus 6 equals 4. Now I'm going to put this 4 over 1, because now when I do this, you have a ratio equal to a ratio, which is a proportion. And now to solve it, how do we do that? We cross multiply, and so we get 1 times 3x minus 4 equals 4 times x plus 6. 1 times 3x is 3x. 1 times negative 4 is minus 4 equals 4 times x is 4x. 4 times 6 is plus 24. Subtract 3x, we get x. Subtract 24, we get negative 28. And there is your answer. And again, if you want to check your answer, we can just plug this into here, and we can check to see if that is our answer. So we're going to have 3 times negative 28 minus 4 divided by negative 28 plus 6 equals 4. Alright, now to finish this up, 3 times negative 28 is negative 84 minus 4, and negative 28 plus 6 is negative 22 equals 4. This ends up being negative 88 divided by negative 22 equals 4. when you take negative 88 divided by negative 22, you get 4 equals 4. And it checks. Again, we are solving a logarithmic equation because x is in our logarithm. And so we want to solve for this. First things we have to do is deal with this fourth power. Realize this can go into the front. So then we end up with 4 log base 2 of x equals 20. So now I can divide by, on both sides, I can divide by 4. That cancels out. I get log base 2 of x equals 5. Okay, now, as we've been doing all along in this chapter, is now we're in logarithmic form. This isn't helping me, so what's going to help me is to go to exponential form. So when I write this in exponential form, I get 2 to the 5th power equals x. So 2 to the 5th power is 32 equals x. And that is your answer. Now, what we have to remember is that the natural log of e is the same thing as log base e of e. These two statements are exactly the same thing. So all the properties that we learned with log are identical to natural log. So when we have a power here, where does this go to? It goes around to the front. So now we're going to get negative 2t natural log e. Well, this ends up being e to what power equals e. Well, this is a 1, so this has to be a 1, so this is always equal to 1. So our answer is negative 2t. Now, this problem is a little tricky because we want the natural log e minus 5. Well, we don't have parentheses, so they don't go together. So we know that the natural log of e right here is 1. So we're actually getting 1 minus 5. What's 1 minus 5 is negative 4. And this expression is e to the natural log of x. But remember, when this value here is out front, it means that it's an exponent right here. So then this is x to the 5th. Now this statement is the same thing as e log base e of x to the 5th. And we learned that if this base is the same as this base, then this whole expression is going to be equal to x to the 5th. And that's your answer. In this problem, what I wanted you to do is I wanted you to use a table and the graph. And what we learned using our graphing calculators is if we graph two separate equations, y1 is 6 to the x. Well, when we graph 6 to the x, we are going to get something that looks like this. 3, 4, 5, and 1, 2, 3. We're going to have a point here, and then 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have a graph that looks something like this. This is the 6 to the x power. Then what we want to do is, let me use a different color. We want to graph y2, which is 5. And this is a horizontal line. So 1, 2, 3, 4, 5. And so then we get a graph that does something like this. So this is y equals 5. So what we want is we want where these intersect, because where they intersect is where this is going to be equal. And so this point is going to be 0.89 to the, not to the 5th, but y is 5. And so the intersection is 0.89 and y is 5. And that's really all I needed on this problem.